All right, gonna jump in and do another stream tonight. We're gonna be coding yet again. Make sure that I had all this stuff correctly set up this time. Okay, good. Tags in a category are doing well. We can close this guy. So I'm gonna notify socials, let everybody know what's going on. All right. Got a few of my friends responding back to me. Okay. It's really great when you have a few channels to yourself on Discord, because then you can just spam everybody all at once. That's the greatest. You know, you can bypass the whole at everyone thing. Yeah, exactly. Yeah, I'm getting a few people tell me that just sent me messages like telling me I should stop spamming everybody. But yeah, no, we're gonna go live today. So I'll talk about what I'm gonna be working on. We're gonna be doing more of the. Let's see. Oh, one more here. All right, I think that's good enough. I think a couple people have joined up. Thanks for hanging out. This will be a good one today. It'll be better than the last one. The last one I kind of had some issues with the drag and drop. That was a little painful of a stream. Not gonna lie. Not going to lie. But that's all right. We will pick up the slack. So okay, so let's go over. I'll go over the notes from the previous iteration. So after I closed the stream off last time. I was struggling with the mouse drag over the SVG. There was a combination of SVG to local coordinates, scaling, and then I basically kind of caved and did a bit of a half job. It works well enough that I can ignore it for now because it doesn't need to be perfect. This is just a tool for testing. So the mouse drag tool does work. I don't have the working version up because we were in the middle. I'm in the middle of a refactor for the mesh grid stuff, and then we'll go into what that means and what I'm creating today. I added some stuff to kind of mess around with. There's like a hover effect over the circles you can drag around, so the vertexes and the nodes can be dragged. I added prettier auto formatting to the JavaScript files just because I was getting a little tired of having to do that myself. And then added the mesh context, and this is what we're going to get into is this mesh context thing. And then after I added it, I realized I need to split it up and did a bit of a heavy refactor on the code management there. And so what we're going to be doing today is going to be mostly test-driven development, probably for the first at least half of this. So I hope I can at least make this entertaining, so we can, because it is going to be some of the down in the weeds, having to do the hard work kind of development stream today. Some more people joined up. Thank you. It's been nice to have you here. All right, so today's goal is to get this UI built up. And so this is similar to what is done in Live2D's Cubism editor here. You get a vertex on the corner here, and you get these control nodes right here that you can move around. The actual grid, the underlying grid that you see, the gray lines underneath that, those are not what we're creating today. Those will be something I'll create in the next iteration. So the idea is just to get these control nodes down. I'll probably draw the Bezier curves on the edges for the warp mesh tool, just to kind of get an idea what that does. Then once I get that, so this consists right now of this simple mesh is 4 individual nodes with 8 control nodes in there. But let's say that I wanted to create a larger mesh. So a larger mesh is going to have more or less the same thing, but it's going to be kind of duplicated. It's going to be a control mesh that happens to have vertices in the center, along the edges, and then these control nodes are along the edges as well. And so these can all warp the underlying grid in different ways. So the more of these you add, the more curve you can kind of train the image or the two-dimensional thing in. And so the tool I got to build has to manage all that complexity. And this is kind of complex because if I go back to the Live 2D and I show you how it manages things, if I drag this vertex, you can see the control node stays in line with the other vertex. And I suspect how, and this is really, honestly really good UI design. I suspect how it works is it follows the rotation of it. It basically converts these converts this into a polar coordinate relative to the other vertex that you're twisting around, and so then it rotates it based on that, and then scales that vector based on the distance from here to here. So it normalizes this distance and then multiplies it times your length of your vector, the vector for this thing. You'll notice that it can also diverge as you drag it around. So there's some kind of drift. I don't know if it's just floating point error or if it's something else. But we'll see what happens on my version. So I've kind of come to the conclusion that I may not be able to support all the things that Live 2D does, and so I should probably just write this to make myself happy, which is what the whole original goal was anyway, is just to see if I can make something work. So that's what we're going to do. We're just going to kind of figure out what looks good and what works for me, and if it is compatible with what they have, then I'll build an importer at some point. This is a really complex, I mean, this is 6 months of work to get to even anything close to this. So all right, so I'll get in and I'll show you what's in the code today. So what is currently in the code today is we're going to be working on these test files. This is my WarpMeshVertexes. This is so this is just a simple class that just maintains the storage of these vertexes, and I want to put the motion. I want to make this thing return clones of itself when you do an update on it. So if I want to move a vertex, it's moved with this class. I thought about different ways of doing that, but I want to make this class more or less treated immutably, and I'll do all the hard work here in the class. And then in my reducer, which I'm going to be using, I'll put the reducer here in the test here. We don't need the prettier open. We don't need package open. We don't need this. Yeah, all this stuff's kind of not important for today. There we go. Now we kind of limit it to the stuff that's important. I did on the app test, I just made it a null test because I needed to get around it. I wanted to leave it hanging there, but it's fine. That's how test-driven development's supposed to be, right? So I guess the first part to start in is going to be on these the WarpMesh vertex tests, because I need to see that I can create these vertex grids. So that's simple enough. It's rather straightforward, I think. So what I would expect to get back from here is going to be a WarpMesh vertex. So I can do this. So it's going to be a mesh size of some sort. That's just going to be, let's say, 100 by 100. And then the vertex count is going to be 2 by 2. I'll need that vector2 from Babylon.js. Now you'll see the tests are live updating down here. Let me move this to side by side. I can close that. That's not going to work for a bit. And then, how do I turn this side by side? I forget. Just drag it? No. Okay, I will, that's not what I wanted at all. There we go. Can I put this up here now? Oh, I swear there was a way to do this. It's always painful when you watch someone not know how to use the simplest portion of their tool that they should know how to do. Oh well, we'll just drop this one and we'll shrink this up for now. On this side, we'll open up the vertexes, and this is the test. And I'll close the, we don't need the file window open. So I'll be running the tests live down here so we can kind of see when things break. For now, I want to do in our tests, I want to say it.only on this so that I don't test anything else and I just get a reduced, little bit of a reduced response so I can kind of see what's going on. So, you know, obviously the reducer is still executing, even though it shouldn't be. It should just say, oh, right, this is just, this file can't be parsed. Okay, no big deal. All right, so I expect this to be an array of WarpMesh vertices that contain WarpMesh vertices, right? Because this is, if it's going to be on a grid that's 100 by 100, I need to define it as whatever the, let's see, WarpMesh vertices. This here, it has a pause and it has its own set of nodes. So I would expect its position on this to be u vector 2 0 0. So this is the top left corner. And then I would expect a second one, since it is 2 by 2. And a second one's position is going to be x 100. And then we have the same exact thing duplicated at the bottom, only its y position will be on 100, 100. And I would expect this to be the baseline grid for my vertex thing. Now this doesn't cover the node handles, but for now we'll just take this and we'll verify that we can get this output. So over on here, I would want to do something like const tested or test equals new warp mesh vertices, new vector 2. This is the 100 by 100, and this is then so this should be what we test, and then I would expect trying to remember, you have to do like get own properties. I'm going to do like a shallow test. So in what I will do for that, so what I need to do is I need to get Jest. I need to be able to partial like test object to so it's like I just have like a light object. So like I have these expected to match object. Okay, so it's match object. That looks correct. So then I would expect my test to match object expected. And now this is going to blow up because it obviously won't. Oh. I thought it dot only would work here. Weird. Okay, so obviously this is breaking right here. So we need to create a new warp mesh vertex. The position's easy enough to discover. That's just a new vector 2, and that's going to be the mesh size.x multiplied by x, and the mesh size.y times y. And then the second one is the control nodes, which we're not testing at this moment. So what we'll do is I'll just pass in an empty array. That's fine. Okay, so now it's getting some stuff back from the test itself. We're getting... Okay, so the reason this is breaking here is this type is not an object. It's I guess these actually the props do exist. I guess it's not comparing types. It's just saying the props are wrong. So it's saying that it's 100, 0, 0. So not 100% sure why it would do that. So this is the vertexes array object. These look almost backwards. Let's see. So did I do something goofy here? Nope. This should just be... We iterate over y, we iterate over x, and we just set those to the right values here. So I'm not actually sure why that's being what it's doing. So yeah, we're all right. So if can't imagine X and Y would be anything unexpected here. So this would just be, the position should be at this here. And if we have, oh. Okay, so obviously that should be right. This should just be right. I don't know why this is not right. So this should be, oh, I know it's wrong. I'm literally wrong with my test. That is exactly what the problem is. I love it. And this should be 0. This should be 100. That should fix it, as long as I didn't break anything over here. So this test should come out valid, I think, unless it does compare the object types. No, it's saying that's 100 by 100. Oh, mesh size not y times y. Yeah, the only thing that's not matching up boy, I have a hard time understanding that sometimes what they mean by here, but it says that the original object's x coordinate must match; those are the same, but the y coordinates. Oh, yeah, this should be 100. That makes sense. Oh, got somebody else jumped in. Thanks for joining. I hope you find it interesting. We're right now going through it, and I'll recap. Probably another 30 minutes. I'll do a recap over what we're doing overall coding. Right now, we're building out this WarpMesh vertex grid to throw it onto the UI. If I get this part working, I might try to make the WarpMesh vertex grid show up in the UI, but that might distract from actually getting the rest of the pieces done here. So in there's another test here, this one here, and it's honestly starting to annoy me. And this isn't it. This is the reducer test. I'm just gonna make it successful just because I don't want to see it, and I don't know why it.only didn't work over here. So it's this test is now passing. So now we can construct the mesh grid vertexes for the default values for the grid. So what that means is now what we have is the nodes for the top left corners, bottom right corners. So now I need to make sure that say a 3x3 can be constructed, and so it should work. I don't expect it. Vertex constructs WarpMesh vertex grids 2x2. Let's do a 3x3. 3x3. Oh yeah, that actually would not produce the correct result. That's great, actually. So this one creates it correctly, but this one here does not, and that's because this one, since it's doing 0 to 1, it'll do the right thing. But our grid shouldn't be bigger than 100. It means that our unit size should be 50 pixels. Here it should be the unit size should be 100 pixels. So I need to figure out what instead of multiplying by mesh size here, I need to multiply I need to do a different number here. So I'll show you how this one would pan out. So this is 3x3. So I'll put the numbers in here. So this will be, the x on this should be 50. Oh wait, no, sorry, that's the other row. So yeah, we should just clone this one, copy to here, and then this is going to be 50, 100. And then this is basically the same thing, only its y will now be 50 for all of these. Yep, and then this one's basically the same thing, only its y is going to be 100. And this is a 3x3 that we're generating. All right. Okay, so now obviously this means that this test fails because none of these match up because the assumptions in this function were wrong. So I come back in here. I need to determine the sort of the unit size. Let's say we'll say xy unit size. So I'm just gonna do we'll say xu, and that's going to be the vertex count.x minus 1. And then so that's going to be when I do 2x2s, that's going to be 1. That's going to be a 1. And then if it's a 3x3, that's going to be a 2, right? And so then I take my mesh size dot x divided by this number. So same thing for the y. Yu is this thing, that thing, and then so instead of the mesh size dot x multiplied by x, we do the x units and the y units, and this should pass both tests, I think. There we go. Test passed. So now this one's generating the meshes that have the 3x3, and they've correctly, so now there's the, if we go back to the example that I drew up, it'll have all the vertexes in the top, left, right, bottom. So now I need to determine how to create the control nodes for them. And so the control nodes are generated, or will have to be generated next, and I have to figure out where those are all at. And you'll notice there's a lot of them for the 3x3 test. If the 3x3 test and the 2x2 test pass, I would imagine that this covers all general forms. I don't think there'd be any extraneous bugs. So when a node is at y0, it can have at most 3 control node groups, right? 3 control nodes. When the x and y are exactly 0, it can have at most 2 control nodes. And so this is how I'm going to determine that. I'm going to look at the x and y as it's being constructed and to say, this one has a neighbor. This one here is the max index for this. So if this is a 3x3, this is on y-axis at 2. So 2 by 0, etc. So the 4 corners are the ones that have only 2 nodes on them. I could do that, like that could be one of the ways I do this, where I just process, say, oh, let's look at the 4 corners, let's look at the edges exclusively, and then we'll look at all the middle vertexes. I don't know, I think that would be a little more constructive work than necessary. So what I was doing here was I was going to calculate the left, right, and top, bottom, or up, down. We'll call them up. This is y minus 1, and this is const down is y plus 1. So now if left is less than 0 or left is greater than vertex count.x equal to, yeah, you just say less than, right? No, I guess it can be minus 1. So what I'm saying is that I want my left to be greater than 0. That way, because if it's on the left line, it can't have a control. It can't have a leftmost control node, right? Oh no, sorry. If the left coordinate is less than 0, because I'm on the 0 coordinate, so my left would be negative, then obviously I can't have anything here. Yeah, that would be great. Okay. And then I also want to say, hey, if my left coordinate is less than vertex count.x, which it can never be that because we iterate, so that shouldn't matter. So if we have a if we happen to have a left coordinate, a left control node, let's go ahead and create one. There is a list of nodes that are attached to each warp mesh vertex. So I actually have to create these nodes before I create the warp mesh vertex. And I can say const nodes equals this. Now the nodes is actually going to be an array, a fixed length array of 4 elements. And so up, down, left, right is how they'll be defined. I should define an enum for the array. At the moment, I'm not going to worry about it. I'm just going to put the items into the array as necessary. So if left is greater than 0, then this dot nodes. We have to do up first. So if up is greater than 0, then nodes 0 equals new vector 2, and this will be the position of it. And so in any case, the position that my vertex is at, I need to know. So let's get the pos out here, and we'll say const pos equals this. Organize it a little differently, I guess. So what it's going to be is it's going to be 1/3 of our unit length. The what I constructed earlier, this unit size. So that's where I want to go. So if I have an up node, so if I do have a control node that's above me, then it's basically the same as this pause subtract, and that's going to be new vector 2, and it's going to be the x is going to be 0. I'm not subtracting from the x, but I am subtracting what is it, x unit over 3 from the y coordinate to go up. Then I do, if up, we'll say if left is greater than 0, so then we obviously have to have a left coordinate. Then I'm going to have pause. I'm going to subtract something because this is to my left. That is going to be the, oh, this should have been y unit. That is y unit over 3. I do x unit over 3 here. This is going to be 0. All right, if I have, let's do down. So in the case of down, I just don't want to be, I don't want my down to be greater than the length of the array or the length of the size that we're iterating over. So that would just be vertex count dot y. So as long as I'm less than, right? And so this unfortunately I need to be -1 here, so I'll have to do that. So that's because if I'm on this vertex, down is going to be this node, this direction. It's going to be, you know, I've got a down direction. I'm not sure what these were all about here, but I think they were really just originally when I was looking at this, I was going to index a whole bunch of stuff. I was going to make these all point to each other for neighboring groups, because they also need to know their neighbors at some point as well in order for the grid to move things around. I think this is why I calculated them the way I did. But if you are on this coordinate, then down is +1. So there's this guy right here, right? But if you're on, and so this is then the y is, I guess it would be less than. Yeah, that would work. Yeah, that's fine then. Nodes. This needs to be up, down, left, and right. So nodes 1. So this is going to be on the y coordinate. Yes. And this is going to be, we're just going to add on the y coordinate. And then on this left one, and then we just say right. So we have the same issue with the same kind of code with the right. Right side is less than vertex count dot x. And so this is 0, 1, 2, up, down, left, right, 3. And this is going to be the x coordinate. This is going to be add over 3. So this should produce all the right nodes for us. I should be able to submit those into here now. This will probably still pass, but that's because we're not testing any of these node positions. To vet the node positions that they're matching, what I will do instead of this right here is I'll go ahead and just I will take from the test, I will say, let's see, vertexes dot I want to look at, so if I'm doing the 3x3, we have 9 vertices. Well, let's verify that there's an array there real quick. Just we'll do an eyeball test, right? So it looks like the top left corner, 0, 0, that one happens to have an up node, which it should not have. Oh, no, sorry, one empty item, sorry. That it does not have an up node, it does have a down node, it doesn't have a left node, and it does have a right node. And so we have to verify these guys. So what I would expect to get here is going to be an array of undefined, comma, and this is going to be, we'll just do the x, y stuff here, x colon 0, y colon, what is 50 over 3. And that would be this top left vertex up here, nodes. And this would be undefined, and the next one would be, the next one would basically be the same thing, it'd be 16, it'd be the 50 over 3 for the x. And 0 for the y. And so I would expect this to continue to pass. Okay, yeah, it passed just fine. Let's verify that I'm not, I didn't make a mistake running the test by just making the test fail artificially. So I'll put a 1 here instead of undefined, and we'll let the test go through. Okay, so it blew up because the 1 doesn't exist there. That's fine. So we can fill out the rest of these nodes like this. And there's other ways to do this, but I'm kind of manually vetting all the pieces of this as I go through it. I could do, I could see if it matches a snapshot or something like that, but I just want to do the manual step just to verify that all my assumptions are correct. So I want to make sure that all these are going to be failing tests. These nodes should not exist for all of these vertexes that we created, right? So these are all going to fail, and I'm just going to walk through and look at what the actual output is. It looks to me that, so this is the top left, this is the middle of the top, so this one has a left and a right and a down, but not an up, so it should be undefined. I should have a left, let's see, up, down, left, so I should have a left here where it says undefined, and they should all be added, so this will be plus 50 on the x right here, right? So this will be 50 plus 50 on the x, and then this will be 100 on the x. 100 plus, these may match. This middle one's probably going to fail. So we're getting one failure, and that's this middle one. Yeah, that's the middle one here, and it may be that this, I did something weird on one of these. So, but the x coordinate on the, let's see, this is the down one and the far right one. This is, what is that? Left, right. It is right. Okay. Should be that. It should be 50 plus that. Let's put the undefined one in here. Let's figure that one out. So this one is a, let's see, it's a down vector. Oh, sorry, this is the left vector, so it should be 50. So if it's going left and it's here, this is 50 in the x coordinate. It goes left, so it'd be 50 minus the 50 over 3. So it would be 50 minus 50 divided by 3. And then the y coordinate would just be 0 because it's on the 0. And I don't know what's blowing up anymore. I could always just decide that these look correct in my head, and what we could do is verify it visually, and if it looks correct, I can just use snapshots and call it a day. Because that might be a lot to try to manually do now that I'm going through it. It's a little confusing to think it through like that. Let's see, so minus 53, y is 0. This should be fine. I think this one is x is going to be the up, down, left, right. So this is right. So it's going to be 50 plus. Oh, this one's Yeah, this control node. Oh right, it should stay 0 because it's a up down node. Right? Because this is up down. Oh right, no, it should. Oh man, this is since the vertical line advances. Right. It should stay 50 right down the center. And Prettier keeps formatting this thing really terribly for me and makes it even harder to stare at this mountain of test data. And okay, so I'm going to drop this second one for now, just to see if we can get one to verify through. Okay, so this is telling me that the first object on the nodes, undefined matched, this was wrong. It says X is 33, but it's giving me undefined. Right, so this should be, I'm thinking this should be defined here, but it's saying undefined is what it is. Let's see what happens with the tests over here. Okay, so that's weird. It shouldn't be undefined. So this is where I was getting confused. The bug's wrong. So, so I think 0, 1 right here. This one should have a left and a right and a down. And I'll go back over here. It has, this is correct. This is its down, which turned out correct. This is its left, and this is its right. But the left is not correctly generated in code. So I think I'll have to figure out what that means. Honestly, this is a little, all I have to really do is just say if x is greater than 0, then it has, then it has a left direction. And if x is less than vertex count, then it has a right direction. Yeah. If y is greater than 0, if y is less than that. These were indexes. I probably should have never used those, but that's okay. So we're getting the same result, it looks like. No, now it's missing the thing that it needs. Okay, so that fixed, I think that fixed the glitch. Aha, so now it generates all the control nodes correctly for the top middle. So let's slap in some nodes for the top right corner. So in order to be on the top right corner, we have, let's go back to here. So top right corner is this control node and this control node. So that's left and down. So we will generate left and down. So this is down, which is fine. So that's just 100. Then we did generate left, but we don't have a right. So we make this undefined. And that should work. Nope, it was mad at me. So it's saying that it expects to get so this test is telling me that it's expecting to get an undefined. So this is right. So again, up, down. It doesn't have an up, but it should have a down. It should have a left, but not a right. And I'm not sure why it would be producing a right. So I think so. It's saying so. This says okay, if I read this right, this is 83.33 is the one object it's matching. Well, what's going to be 83.33 is this 100. So this is what it's matching here, is this 83.33. Then this undefined, and there's something else that comes after it, or it expects to get a 116 here. So that means it thinks it's trying to produce it's trying to produce an extra vertex too far to the right. Is this the correct answer here then? Okay, so it does need to have a -1 here. Okay. That's what it was. So now it generates all those control nodes for that side. And they'll basically be the exact same locations for all of these other these vertexes. The only thing that'll change is the y coordinates on them, since it's just moving down. So like this would just be that, and this would just be that. And I need to add a comma and a bracket and a comma. All right, so this will fail when I put this in here until I add 50 to all of these y coordinates. So it just be 50 plus this. I think that's it. No, what did I miss? Oh, that's even weirder. It expects different stuff. Oh, right, because this middle node's going to have ups on all of them. So they are all going to have this node here, which is basically just a reflection of the down nodes. This is then 50 minus this. And they'll all have this node since they're on the same line. I did something a little funny here. I put an x50 where I should not have. This one should have 3 nodes. Y is 3, 3, 3. So this is, well, I don't know which one this is. So for now, let's get rid of that one. Oh, this. We'll go ahead and pull out all these, I guess. We'll just do like the first, we'll just do verify the first row, and then so I'm pretty sure that row is correct. And we'll pull these out. and see what happens. Okay, that passed. Will this pass? This one does not pass because it needs, this is the third vertex, so it's this one here. It needs an up, a down, and a left. So the first three elements should be defined, which they are, and the last one should be undefined. So that's the first thing to notice. It thinks that there is a issue with the x coordinate. It thinks that x is 0 on one of these. Oh, this should be x of 50, I think. No. No, it shouldn't be x. Wait, that's confusing. Why would I make it? So up and down should have the same x coordinate. So that should just be the problem right there. Right? Why does it think that it needs to be? Oh no, sorry, as the, oh right, this x coordinate of this vertex is 100, so this needs to be x of 100. Wow, which these were like relative. That would make things way easier. That maybe that's what I should have done, made them all relative, but they're not, so let's have to carry on. It is on the center line, so it has to be a 50 on the y coordinate. So this one has to be an x of 100. This is then 50 on the y coordinate, plus because it's down, minus because it's down. This is also then x on the y coordinate, but since it's a left control node, we subtract 50 and we put it on y of 50 as well. So this should match. Is this correct? Okay, okay, that's what I was missing. So now this is the center node where it generates all the goodies, where we have a lot more control nodes. Oh, we should have all four basically at this point. In order to get all four control nodes, I have to calculate up, down, left, and right, but I can copy the left one to the right one, and we will just, instead of doing minus 50 here, I should just be able to add. That should be the center, fully do it. It did not. Something blew up, but that's okay. Let's figure out why it blew up. It's getting x's of 100s, right, because this is on the center line. We need to move that to 50. Like this. And that should fix it. All right, so now these mesh grids are being generated correctly. I think, pretty certain that they are. I'm happy with that. So now what needs to happen is I need to render these somehow in the system. So let's go back into the other development. Now I'm not going to integrate the context and the reducers. We're just going to create these WarpMesh vertex grids manually, and then once we have them in the app, and again the app's getting kind of crowded. It's a little dirty of a piece of code right now, but that's okay. We'll just throw it in there and worry about the logistics of it later. So I need to pull a mesh grid in. So we do these WarpMesh vertexes. This is in CTX. Oh, that worked. Okay. So I'll have to do something to be able to draw the WarpMesh vertexes as well. Like, how do I add them to my primitive routines here? So in primitives, I need to add a new primitive. We'll say primitive. Actually, it's probably not a primitive really. That's for now. It's fine. Let's just call it a mesh vertexes. So we'll put this in. No, that's fine. Export function. It needs to have the React song and dance. And then I'm going to, for now, we'll drop that. This is mesh vertexes. And we'll do props. I don't really know what it needs for props right now. It's really not going to have any. So this is going to return back SVG elements for this mesh grid that we're designing. So this will return back all of the points just drawn in their right locations. So that should be simple enough. We're just going to do a const, we'll say mesh, and we'll say set mesh, use state, new mesh warp mesh vertexes like this. The mesh size is going to be new vector 2, 100 by 100, and then we're going to set the number of elements we want to new vector 2 of 3 by 3. And vector 2 is being brought in from Babylon, so we'll do that. All right, so I now have the mesh in a state variable, and so now I need to go and loop over all its vertices. So I need to say, let's do this. We'll say const vertexes equals mesh dot vertexes dot map primitive circle. Key equals, let's do this, v comma I. Primitive circle needs a color. We'll just say it's red. Then we'll say it needs p1 is equal to the point that we're at, so that's going to be v.pos. Right? Isn't it pos? Do we not have... Oh, that's interesting. Wait a minute. Why is it an array? Oh, right, because the vertexes are a two-dimensional array. Okay, yeah. Okay, Oh, yeah, if they're a two-dimensional array, then I probably want... All right, let's just do this then for each. Ooh, man. I got my fingers back in the home row keys. Yeah, I'm just gonna iterate over it the old-fashioned way. Mesh. It's not that. It's mesh. Vertex count.x x plus plus. We're just going to create an array, and then I'll push all the primitive circles into them so the array is linear. I probably could have flattened the array, but this probably is... Like, I could even go so far as to say this is a new array of this times this. And instead of pushing them, then I can just say vertexes. So it'd be x, it'd be y times vertex count y x plus x is equal to primitive circle key. This key should be the same as this index here, so let's just calculate that. Should just be I. And so now it's going to be const v is equal to, let's see, vertexes dot, no, sorry, mesh dot vertexes x, y, and then this is v dot pos. There it is. Okay. And I need to bring in primitive circle. Was it not allowed? Oh, did I do something wrong here? What's it mad at me about? Oh, R is missing. Okay, so R is equal to, let's say 5 for now. So we will put the vertexes in there. So now this should render vertexes when we add it to the app, as long as it builds correctly. Yarn start. We'll be able to see something. It's always good. All right, so we have our browser here. Should load this up. All right, so this is the stuff I had from the last time. Like I can move around these two dots. They have drag handlers on them, so that's great. Little button for something. I don't know what it'll do, but I got a control panel just kind of mocked out. Yeah, so I think what next needs to happen is I need to obviously put those in there. One of the things I realized I didn't include on the WarpMesh vertexes, there's no provision to translate the whole thing. It just creates them all at 0, 0, which is kind of like not probably what I want. So I need to add in something to do the initialize with translation. And I might do a half-ass test on that because it's going to either work or it's not going to work, and I don't want to write, you know, this giant cluster again. But yeah, I think I need to add something like for, you know, start position for top left corner. So if we come back to the app and I want to put the mesh vertexes, and these should effectively be capable of being like a primitive. So if I slap them down inside of my primitive area in any capacity, I think. So this thing that takes no options right now should compile. Hey, there it is. All right, so that renders all the vertexes. It's a little tiny, so let's make it a little bigger. Let's pin this left and right for now so we can watch it. So let's make them a little bigger. I'm going to also just kind of cheat. I'm going to come over to this. Let's see. Oh, yeah, I don't have... Oh, man, that's going to be a nightmare. Oh, I do calculate... Okay, no, actually, I can just add 100 here. Why is that auto-reloading? That's weird. So I can move these out of the way. And I also want this to be bigger in its original. So let's make this 300 units by 300 units wide. So it's larger now. And then I also want, I need to render all the handles. Const for, let's say, handles, new array. This is going to be, oh wow, I don't actually know how to calculate the top size of that. That's because it's yeah, I don't know how to do that off the top of my head. I'm not, it's not important. So I'll iterate. Well, I don't even have to do it there. I need to do it here. Yep, like this. So then I will, on each one of these, I will say for I equals 0, I less than mesh dot, no, this is vertex, so v dot nodes dot length handles I equals, so this will be another primitive circle. We'll make the radius 3. That's probably a little tiny. I need to do I plus plus. Oh, I so overrode I. This is going to be in I, in the land of. Oh, it needs to also have a let. Yeah. So handles dot push this guy in there. So now I'm pushing the primitive circles into this UI element. Uh-oh. Oh, the test failed because I just manually, like, just hacked the, that's fine. That's fine. No one cares about passing tests anyway, right? Passing unit tests, what are those? We'll make these green, and these are just going to be nodes ni node equals v.nodes ni, and if node, then we push oh, the point can just be the node, because the node, all that is a point. So that should work, and then I should get, oh, I need to add them to the output here. So handles. Oh, look at that. Excellent. Excellent. We got the whole shebang going on here. All right, so let me see if I can refactor this to have the offset in this vertexes here. It needs a pause like this, and this would just be pause.x, and this is pause.y. That's fine. Wait, why is it mad at me? Oh, huh. All right, so now when I construct it in here, new vector 2, 100 by 100. Okay, so now they can render just fine. And then let's verify that I can do like something else with it. Say 500 by 550 or whatever. Okay, so it still moves. Like I can put it wherever I want on the screen. It's doing great, looking good. And all right, so now that I have the handles up there, I need to make them draggable, and draggable or drag is all like in the app in the wrong place. So let's refactor that real quick. We'll put it under components. We'll do we'll do a new folder. I'll say draggable file draggable.tsx. And then we'll start moving all this fun stuff in there. So the drag handler is my event tooling to and I need a React, and it needs a event emitter, which I think I got here. What else did it need? Vector 2, which I think like everything needs vector 2 now. It's just bleeding its way everywhere into the code. And I can do an export on the drag handler, and I can do and export on the draggable, use ref, use effect, and that should make it work. That should be good. Okay, so I also need to fix my test that's blowing up because it's bugging me. We need to create a new vector 200. This doesn't technically test all of the branches of possible threads of execution. You would probably want, like, if you're trying to be complete, you would want another vector that positions this somewhere else on the screen. Oh, the app. So this is why I did the app smoke test that didn't really have anything in it. The app test itself is blowing up because I have some. I did React no-nos where there's some stuff going on. And this is just an ESLint bug. So in my MeshVertexes.tsx, it's just mad that I didn't do this, which I don't know. That's silly. Like, why? Draggable's not defined in app.tsx anymore because I moved it. So let's get that imported. Let's see if it pulled in the right draggable, because I actually have, okay, good. Pulled in my draggable. Let's see if it compiles. Element is not pushable, type parameter never. Okay, so see, oh gosh. It's mad at me for pushing this into that because it's an empty array, I think. No, that doesn't make sense. Why does TypeScript like this, but it didn't like the other? That's fascinating. I think it'd work if I did like an any array here. If I did this and just define it as this, like that satisfies both TypeScript and React. So I'm definitely doing something in React that's probably a no-no. So let me get these handles draggable. They probably need a little bit bigger. So I'll probably make these more like 10, which seems egregiously large, and these 5s. Oh yeah, it's like huge, but it's fine. Also, one other thing we should do here is I need another control node that this thing generates. So it needs a control, which is just really going to be a draggable primitive circle, and the point of that is then the whole entire mesh itself can be dragged around with the draggable system. And that for now, that's what I'm going to do. I'll have to do so. I'll probably want to do something different later. So like if we have this open and I'm looking at the warp mesh here, how this does its thing. That's so fascinating. I can't wait till I get to where I'm the more bread and butter of this warp algorithm, so I can kind of understand it, because it's just really interesting how it works. Okay. So I need to make these draggable. Let's just throw draggable over all of them and see what happens. Like this. So obviously nothing's happening right now when I do make it draggable. Oh, it's mad because I don't have draggable defined. And it looks like the props can be any, which that is not what I would have wanted. I want draggable props. That is a function that takes a, I guess a pause, and it's a vector2 that returns nothing. Like that. This can be Oh, I see what's going on. I'm adding multiple. Okay, that's not a problem. I can just do ni, this ni, and I can call this one, I don't know, handle. And then up here, I can just call this vertex. This is vertex I handle I. So this should stop. Oh, no, it is not. I don't know why it's still blowing up. Let's see. It's primitive area, draggable. It really should have had its own unique vertex with this definition. It could be, I don't know, it could be the handles could be doing it. I don't know. Let's see if the handles cause the error. No, the error is happening. Huh, I don't know what's going on there. They should be unique indexes. It should just be. I wish it would tell me what key was colliding, or maybe they don't have keys or something. Is it mad because of that? No, I didn't think so. I probably need to keep that. Let's see if it's mad because of the first of all, the key needs to go up to the draggable now because, you know, reasons. Draggable, why? Oh, I didn't ever define the props. I defined it but didn't use it. Okay. And this is then on drag equals. We'll just do a no op v. Oh, it's supposed to be void. So void on the return type. Draggable key vertex I. This should be unique. Oh yeah, we're not getting errors anymore from the. Perfect. Perfect. So they're not draggable yet. Why is it mad at me now? Oh, because I didn't. Oh gosh. React props with children. Still mad at me? It should have just refreshed. Okay, great. So this is probably throwing draggable events right now. I need to change the mouse cursor when these are draggable. And it doesn't do that. Okay. So those are probably draggable, but there's no way to actually move a vertex at the moment. So I'm not currently maintaining the mesh vertexes in any known state. So the way I was going to do this incrementally, the mesh vertexes, when I want to move a vertex, I can just tell the warp mesh vertexes here. Let's see. That I want to move it, and I want to drag it based on the index number because I think that'd be the easiest because I got to clone this whole construction. Say index colon number and pos colon vector 2. So this is just, hey, where do you want to move this to? And this is actually going to return back an entire new copy of the warp mesh vertexes array to make the whole thing immutable. So const result equals, we're probably just going to do self dot clone. I'll just create a clone event or clone function because I'll probably do this for the other thing as well. So I need to do a clone function. Clone function returns back this, return. I don't know why I did that. Okay, whatever. New warp mesh vertexes like this. and it needs to know its position. So that's going to be, you know, self.pos. Is it? Did I ever set that? Oh, I did not. I need to set that. That was one of the other things I remember to do. So position vector 2, because we'll use that position to also track dragging it around. This dot position equals position that dot clone. Using a lot of clones just because I should, just for now, and if it ends up being slow, I might do something different. I might use a different vector library. The Babylon.js vector library doesn't like being overwritten in some cases. It tends to be a little. It's made for a graphics engine, so it tends to do a lot of. It has like a lot of in-place calculations, so it's like kind of not the right match for what I'm doing. But I know that all the vector stuff I do later is going to be in Babylon.js, so I'm thinking like, if I can just use them all the way through, it'll make things easier at the end, on the end. And there are great benefits. They do have the ability to do a lot of the word I was looking for. Oh, in-place stuff that'll help with speed if I need to do it at some point. So for now, just duplicating things, no big deal. Dot position. Or this. What am I doing self for? This. Dot position. Is that all that Python code I did at the beginning? That's what's doing it. So this dot position, comment this dot mesh size, this dot vertex count, like that. And so this is going to end up creating a whole bunch of new vertexes immediately, which we don't really want that. I guess we don't want that, but I'm kind of the opinion that, see, this would, if I duplicate all of these individual nodes, man, maybe the class was not the right direction to go with this, because I don't want to initialize them. I don't want to create a different constructor. I could just dump the nodes, but anyway, if I create a new, so when I return this back as a cloned example, if the reference to all of the vertexes changes, if it's no longer the same reference, then I think it'll force a redraw of all of them. Is that how that works? I don't think it verifies them all the way down to the individual properties. Yeah, this could end up being where the situation gets to where it's like having POJOs as all of the data would be better, at least for the React side, for the reconciler and all that stuff. But I'm just gonna not worry about the details, and again, if it's slow or something weird happens, I'll refactor it then. I don't want to overthink it. So this is simple enough. This doesn't clone it. What I need to do now is say for, let's say, so the vertexes are in a two-dimensional array, so I need to iterate over all of them. I need to then be able to clone each vertex, so let's add a clone function here. Clone, this is return new, WarpMeshVertex. This dot, one of the things I noticed is that I'm not cloning here, which I really should be doing, just because I'm trying to make sure I don't keep inappropriate references all over the place. Like I don't want to have a reference to somebody else's vector in my library. I want to keep this itself, so just in case I do something silly with moving the stuff around. Okay, so WarpMeshVertex, it's gonna be this dot pos and this dot nodes. Nodes can't be cloned, but nodes dot map in dot clone is that thing, like that. This should work. That's a clone of my WarpMesh vertexes, and it's not a, a clone because, oh no, it is because, yeah, I'm cloning, I'm copying everything. This one works fine. So this one works completely. The issues with WarpMeshVertexes here is it doesn't take an input mesh. And maybe that's what I need to do. Since this is generated initially, right? Maybe this should just be a class function, and then I'll pass in. Boy, that would be. I could do that later. I could do that later. I don't have to worry about it now. But I could make the class function that just generates this stuff, and that's just what you feed into the initial vertexes. Or maybe there's an initialization step that happens, and that's what sets this up. That way we can skip it when we don't need it. But for now, just going to take it. So it's going to be this.vertex count, this.vertex count. Okay, so let's see, moving the vertex. So that should work. So that's a clone now. So this is an exact duplicate of the warp mesh we have, and then this is going to be when we move a vertex, this index is not what we want to move, or I can do it. I would have to do it by XY, right? So I'd have to say X colon number, Y colon number, and then the position it moves to. So then I would say result dot this clone. So this is an ideal copy. Then I can say result dot vertexes X Y equals result. Let's see, dot. I can update this one in place. I can just say pos equals pos. So this is move vertex, and then I can return result. So this should be correct. I would like to at some point get this in some statefulness testing, like obviously, but is missing the warp test vertex. This is a weird one. What is going on here? I do not understand what is happening here. Well, this is weird. That makes no sense, because this file is defined the own. What? Is it the compiler that got out of weird state? Did something get in a weird state? Is the universe wrong or am I wrong? Normally you're wrong, but you know, you'd like to think the universe was wrong once in a while. TypeScript error in WarpMesh reducer TS, it's saying that the type mesh size vector 2 is missing the following properties from type WarpMeshVertexes, clone, move vertex. But I don't. Oh. Oh. Okay. Okay. I see what's going on. You can't just duplicate Pojo like this. That should be pretty obvious, I think. What I need to do here is the move vertex is just going to be an alias of the so it's going to be state dot move vertex, and it's going to be the payload action dot payload dot x comma y comma pause, because move vertex, you know, does all the duplication of state for you, which is kind of why I wanted to do it that way. I've never really done it that way before. I just thought it might be interesting. And this is pause vector 2 like that, and we need to bring vector 2 in. Man, it literally bleeds into every file. Okay, vector 2. So now move node's going to have the same thing. It's going to be an XY, you know, pause, but it's also going to be an index, I guess. So yeah, there'll be an index number like this. I can just for now return state literally because I'm not doing anything with the. Okay, so now this, I'm not using this reducer yet, but the code has been factored. It should work fine now. Let's see what happens when I rebuild this. All right, so that built just fine. Let's reload it. So I'm definitely getting the move event, or at least I think I am. So I now need to then map the drag event to the set mesh action up here. So let's do const drag mesh vertex. And this is going to be p colon vector 2. Now, knowing which vertex I'm dragging is going to be important. So So what I'm doing here right now is I need to, it's like kind of like a JavaScript thing. So the X and Y variables in these for loops, they lose scope as you generate this stuff here. So if I try to refer to them in the onDrag handler, when we drag, I would only be referring to the X and Y handler of the last X and Y number that got enumerated, because that's the reference that stayed in the X and Y the thing here, right? There's no function being called. So if I call a function to generate this entire thing, then it would trap the XY value in that function, etc. There's a lot of ways to handle this, but what I'm gonna do right now is I'm just gonna create a function that generates a drag mesh vertex on drag whatever handler, and it takes an XY and then returns a function for that. So when I do this here, and I just say this is this thing here, and I say XY, when this function gets called, the values will get saved, the XY will get saved in this closure scope here, so that I can just then call the set mesh of mesh dot move vertex XY comma mesh dot vertexes XY dot pos plus p. Dot add p. And in theory, that should let me drag everything. I think I should have a draggable grid now. Oh gosh. And I have nothing. Oh, I gotta refresh because it's being... All right. Am I getting some weird messages here? I am not getting anything. Okay. I am wrapping draggable around the primitive circles that are red. Let's make them blue just for a sanity check. They did switch to blue. So if I drag them, nothing seems to be happening. Oh, okay. That's first and foremost, that's part of the problem. This needs to be like this. Whoops. I need to call this function as the drag. It's a drag handler constructor, so it doesn't. Okay. Hey, that's what I'm talking about. So now I can drag the handles all over the screen, and we can kind of get a bit of a pseudo, it's getting there. It's not quite a UI yet, but I'll make a UI out of it. And these things are really processing a lot of data in the background, cloning that grid around and all that stuff. It's probably not, like long term, it probably isn't tenable. It's fine for now. What I also need to do is I need to draw the grid lines between all the vertices. And since I need to draw the grid lines as well as the individual vertices, I might not want to push the vertices into that array. I'm trying to think of how I want to handle it. I do want to throw the lines, const lines. So I'm going to create the lines array. So we're good here. It is generating a bit of a mesh. We're at the 1 hour 40-minute mark. That's great, because it means I can probably get the full Bezier looking curve editing stuff in. I suspect I can get to that end goal, which will be nice. And then I'll probably be able to also integrate the statefulness for the warp meshes into the context. So because I want to put state management with these into contexts. I think I'm not 100% sure how I want to handle it, honestly. These warp mesh vertex classes with the instances that they produce seem like a decent. Like, this is not a bad way to handle state at the moment. It might not be the best, but it's not bad. I've seen worse. And it's really isolated, so I may just lean on this for a little bit while longer. So we'll see how that goes. Let's construct the lines. So let me think about how I'm doing that. So if I iterate over, from left to right, I probably just want to do the lines separately from the vertices. I'll I'll generate all the horizontal lines first and then all the vertical lines. Yeah, that makes the most sense. Right? Yeah. So let's just iterate over the grid all over again, and we'll just create the lines down here. It's like one of these loops will do just exclusively all of the vertical lines. So let's do this one. We'll do all the vertical lines. So it's going to be lines dot push. Color will be, we'll just set it to green for now. I don't really know what I should set it to. P1 is going to be equal to, this is going to be -1, -1. And then the P1 is going to be equal to mesh.vertexes x, y, and P2 is going to be equal to we actually need this to be all the way because we want to go through all the lines. So I'm going to do all the vertical lines, right? So I need 0, 1, and 2, but I only need 0 and 1 for the other index to go vertically. So we'll do P1 is equal to, well, we'll just do P1 then. And P2 is equal to, we'll do const like this. I probably don't need to pull those out. Is this something wrong here? Oh, right. This is dot pos dot pos. So if this is going y down, we need a y plus 1. Okay, so this should draw a straight line. Now this isn't going to be our Bezier curve, right? But we should have a set of straight lines when I refresh, or not. Oh, because I didn't put the lines in. I need to draw the lines here in the thing. There we go. That's all of our horizontal lines. And then I need to do. Why did that? Wait, that shouldn't have done horizontal lines. Wait a minute. That shouldn't have been horizontal lines. Am I wrong? Did I do something strange? I would say, so I'm gonna, okay, I'm iterating over x, so I'm starting at 0, and I'm going all the way to 2. So, right, because this is 0, 1, 2. I get 3 coordinates for x. Y gives me 0 and 1, but I get 3 y coordinates. I then look at the P1, which is my x coordinate. And did I generate these in a weird way? Did I encode these as y colon x versus x colon y? Maybe I did that. WarpMesh Vertexes. They're encoded yx, which is efficient. This is memory efficient, but I keep referring them as xy, so that's bad. Man, that's a hard one to. So vertexes xy, xy, they should be all yx. So this is here, this should be y. So the reason why when I was moving it that they didn't actually do anything stupid, the reason they moved around is because I had everything referring to them as xy versus yx. This one here, this is yx. I will think that should fix all of them. Okay, this makes a lot more sense now. But so now when I drag them, the straight lines will drag with the mesh grid. Oh, something got weird there. YX, XY, dragging XY, YX, color, drag vertex. The drag mesh vertex might be doing the wrong thing. In this move vertex, we do YX. Something got weird. Okay, oh, it's flipping the grid X to Y every time I drag, because I did, oh wow, that's great. So the clone is not correct in here, so we iterate over all the Y, then over the X, and then for all the YXs, we do all the XYs. Ah, that would definitely break things. Okay. All right, so now it should, yep, it drags without doing that flicker, so it's not cloning all these various, you know, objects in here. So let's draw the other set of lines. Let's do that. Now eventually what we'll do is I'll get the control nodes wired up to draggable, and also the control nodes will move with the vertexes as well. Once I get the control nodes moving with the vertexes, then I'll also get the Beziers being drawn as well. So I'll have the outside of the grid, and I'll be able to warp everything internally. Then maybe just maybe I'll come up with a way to start plotting the actual grid space within it. You know, so that way it's actually a thing now. That'd be great. That'd be a really nice little. That gets me 90% to where I get to start solving the problem I want to solve, not the problems I have to solve to get to the problems I want to solve. That is actually probably 90% of programming. It's solving the problems you have to solve before you can get to the problems you want to solve. And this one will iterate over Y like this, and then we'll iterate over X like this. And this one's just going to be Y, and this one's going to be X plus 1. All right, so there we go. We're drawing my simple straight line mesh overlay. I'm digging it. So then the next thing I want to do is, I think through this here. I want the nodes to move. So I'm pretty convinced that when we drag here, the nodes, the way they move, it's kind of a special like thing that they do with them. But I'm going to go ahead and not worry about that. I want to make the nodes move there. I want to make the individual nodes move. So here we go. So this is when I take the result after cloning it. I take the result and I go ahead and I clone that here. And in this situation, I'm saying, hey, vertexes xy pos equals pos. I'm going to just go ahead and say result dot vertexes y x dot we'll say move in place. We'll set in place pause, and then I'll just put a function in there that will update the vertex itself. So I'll add that function to this. We really don't need this function because I'm never going to use a function like this with the rest of the, yeah, no. I'll never use this function ever again. It's really only being used just for now. So we'll just set the pos here. I need to get the original pos, so const p equals like that. Let's assume that the pos that's being this position that we're getting in is a vector that's say forward in space, so it's greater than the original position. So I want to say pos minus, so that's dot subtract. So now they've subtracted that from there. I now know the relative position that's been moved, the relative amount of position. And to be honest, all of my UI works on relative positioning anyway. I could make this just a relative, you know, equals pos. So if I say, if I just say p is equal to the original position, and I then say the new position is going to be equal to the p.add pos. Yeah. Yep. And then I need to change over in the mesh vertex, or this thing, that the drag stuff. Instead of doing the add p here, we literally just send p because it's now relative. And I'll go back to this thing, and so now I can take all the individual control nodes and I can add to them as well. So I can say result dot nodes. Oh yeah, it's vertexes dot. Yeah, what am I doing? I could just do v here equals this dot vertexes xy. Right, and then I could just say v dot pos dot add pos. That's fine. And then, oh, yeah, whatever. Nodes equals nodes dot map. What is map? Doesn't map skip undefined indexes? I think that's the case. So where'd my, this is, no, that's not my browser. So I think array map undefined. I think if it hits an undefined, it does it stop on an undefined? I can't remember. I thought it did, but here's how you always remember these things. You just ask the computer. So if I run this, obviously I get that. If I say like this, okay, so it doesn't skip undefined. Okay, I don't know why I thought it did. Maybe I've been writing too much C lately. I've also got another project I may start streaming at some point where I'm doing a lot of old retro like DOS x86 coding stuff. That may be interesting to some people as well. But I'm gonna try to get through this Bezier mapping thing that I've been building for a while, just to kind of see where I can take it. Okay, so I can just do map here. So this is going to be v.nodes.map, v.nodes, v.nodes. Oh wait, this is n dot. Oh, n is already a vector, so then I just add pos. So that should move the control nodes for me. So now when I drag a vertex in the UI, or oh, it's here. Oop. The control nodes it shares. Okay, there we go. So the control nodes it shares moves with it. So excellent, excellent. Let me get rid of this console log I slapped in there. Those things they're like a plague once you start adding them if you don't pay attention to it. Where did I put it? It's in this. Okay. So this is excellent. I can move this around. Oh, we're getting there. This is what it's going to take to make this this tooling work. I think I know how to generate the grid that goes underneath this for the warping effect, so I'm kind of stoked. We're getting there. So now I want each. I need to. Well, one thing I'd like to figure out is this. What's going on with my keys? Why this is being a jerk? It's mad at me for this. Oh, maybe it's not mad at me for this. Maybe it's just I didn't run the test for a while. No, it's mad at me for this. Okay, so oh, it's probably because I started adding these lines. The lines don't have keys. So the lines should be, we'll call this, this is what these are vertical lines, because yeah, these are V line underscore, and we'll just call it whatever the X underscore Y is here. And then this key will be the horizontal line, so H line. Hey, look, test passed. I mean, this is moving good enough. I mean, other than the weirdness I have with the relative motion of the mouse that keeps getting off, it seems to be working okay. Good enough for now. I can fix any bugs with that later. So then I'll do, let's see, let me think this one through. Oh yeah, okay, so I need to start moving the drag mesh vertex. I also need to do I need to also encapsulate this index. So I need to do another one of these. This is going to be drag mesh vertex node. That's going to be an X, Y, and an I. And this is going to be P vector 2. This is going to be a vertex node, NIP, X or XYIP, yeah. If I do right? No, this is going to be X. Okay, it is going to be that. Then I do, let's see, drag mesh vertex node. This is a const vertex node. Then I would need to leave that in. Is there a move vertex? Oh yeah, there is. There needs to be a move vertex node. Vertex node. And for now, we're just going to clone this and return the clone. So now we can just return this result. Sorry, my got a little out of sorts there. Okay, so let's see. Okay, so this is just returning the clone. It's not doing anything. This is probably just exploding because I did something silly in my... Yeah, let me go back to the mesh vertexes TSX. This, it's mad here because it's not move vertex, it's move vertex node. Like this. Well, vertex node should take 3 arguments, so it's going to take an ni colon number like this. So that should work. So now I can still drag these around. I've got the draggable stuff hooked ready for the handles, but they're not quite, you know, there yet. So let me, one moment, I got a slight distraction I gotta deal with. All right, so the move vertex node. So now I should be able to, the move vertex node should be actually really easy to write. Let me get the, yeah, because all I need to do now on the move vertex node, I just clone it. I need to get my vertex reference from the original, and then I look up the individual node. So I say vertexes yx nodes node index equals result vertex node index. Well, actually no, I just do that's right. And the nodes node index dot add. I think dot add pos. I think that's all I have to do. I don't even need this at all. And then I don't need this thing anymore. Get out of the search function. All right, so now if I bind the, all right, go back to this here. So now I got this drag vertex node thing, and if I push draggable like this, on drag equals this thing, x, y, ni. And inside of the draggable is my primitive circle. Let's save that. Then I also need to move the key up to the draggable. Boom. All right, so let's see if it functions correctly. So I should be able to move the, ooh, wow, it's really stuttery. It is. It dropped performance really badly on this last fix. But I can move the control nodes. So yeah, I think I've lost performance. I did. It's probably because this is just absolutely horrendous on the DOM. Let's see what happens when I move. Is it not showing me updates? Do I need it to enable that or something? So that's lines. I need to get out of lines. That's a control node. So let's see what this control node does when I move it around. Well, it really only updates the one node. It is correctly updating that only that property on that node. So the reconciler is still doing great with React. And the nodes do follow the parent line or vertex. I mean, but yeah, it's like it's missing events now or something. I'm not getting errors. It's just, let's see what happens when I'll do a performance, record that. I turned on the record performance and it decided, oh, these aren't terrible. I mean, it could be better. Let's see. It goes all the way down to this doesn't look that bad. Where is my code at? How far down the flame graph is it? So I want to see what my clone functions do. Mesh vertexes, something about a third of a millisecond. I mean, just outside looking in, you know what I'm seeing in this this drag cycle when I move. You know, this is kind of like you know, these sticks that hang out here on the flame graph. These end up being very much like kind of like your frame rate, right? And so if I just kind of narrowly zoom in on one of these and just say, how wide is one of these? It's 2.5 milliseconds. Like I can tolerate 2.5 milliseconds. I don't see anything that really like screams like, hey, this is broken and you can fix it. I don't even see the clone function showing up or anything like that. So it might be the debugger just being open causes it to be slow. It feels fine now. Okay, so it's probably the debugger. Yeah, it gets glitchy with the debugger open. If I get it off the elements, maybe it draws better. Oh no, it does not. Well, I don't. Oh man, I don't know why it's so bad. Oh, let's turn off things. I got nothing. So when the debugger's open, it can act a little slow. That's fine. I'm not too worried about it. I will. It might also be that if it's like selected, maybe if I had something else selected. There may be an explanation for that. Let's see, a Chrome debugger open. If the debugger is open, I don't know, render slow script. I don't know, we'll see what happens. Yeah, I'll look into that. I'll look into that when I get offline today. We should be able to get the Bezier curve things going in there, and we'll sort it out. So I have two options for the curves. I can draw them manually, like with my own the own Bezier functions that I wrote, or I can do them with the SVG stuff. With the SVG, it might be a little more, maybe a little more difficult. With this, when I draw a line, I will have to figure out what control nodes contribute to that line. So each pass, if I do like, so I'm doing vertical lines here, right? So that means that it's the top node and the bottom node there. I guess that does make it easy. 0 and 1 is what this would be. And then this one's 0 and 1. Yeah. So const C1 is this mesh like this. Oh, I can just do P1 dot nodes. So this should be the topmost node. So I want the top down. I want 1. It's my index here. And then I want C2 to be P2's up node, which is going to be 0. And then I want primitive 0 line instead of that, and I'll put C1 equals C1, and C2 is equal to C2. And so now I'll drop a primitive Bezier line into my primitives. New file. We'll just duplicate the line code. It's pretty close. Primitive Bezier line. And then, okay, so in order to make a simple Bezier line, let me look this up in, we'll steal this, nope, this is a browser. Okay, so SVG Bezier line. I think I just need to use the path, and I'll have to do like, I'll do like the path commands or whatever, however it works. I think I do a curve to, yeah. So you do a move to, and then these are your control points. These are, so capital is absolute positioning, and I think the first 2 are your control points, and the last 2 is your destination point. Yeah, line should end. The other 2 are the control points. So I got to do an M. So I'll do a path. So it'll be, is it just P? I think it's just P. Oh no, it's path. Okay. So path. And then D equals, we'll do a, we'll backticks here. And then what I'll do is do a move to, and this will be an absolute move to, since it'll be capital, and those will just be the p1.xy coordinates. So we'll do p1.x, p1.y, then it's going to be a curve to, then it's going to be, I need to put C2 here. This is primitive Bezier line. Props C1 vector 2, C2 vector 2, P1 C1 C2. All right, so then I can curve to, it's going to be C1.x, then it's going to be C1.y, C2.x, C2.y, and then it's going to be P2.x and P2.y. I think. And it's compiled. That always means it works, right? Isn't that the rule? If it compiles, it works. Uh-oh. Okay, so what's probably happening is it's probably doing, the nodes are probably not correctly defined. So what I would like to do, instead of just, throwing an exception, I'll just say if C1 and C2. Otherwise, I just won't push the lines in there. Okay, so I've completely lost all my lines. No big deal. Oh, this should be P2 nodes 0. That could be part of it. Oh, I didn't put a stroke on it. That's what's going on. Yeah, so it's working. Okay, let me put a stroke on that and make it not closed. So this needs to be a stroke color. Oh, wait a minute. It should have a stroke color already. Yeah, let's do fill transparent because that could be part of what's going on. Oh, right. I didn't put a stroke color on this. So fill transparent and stroke equals color. There we go. In the primitive line, we had a stroke width set up. We had it on a style too, so I don't know if it matters. Like we did this. Yeah, so now the grid, man, that is really terribly slow when I have the debugger open. It works well with the debugger closed. I got to figure out what the issue is, or I might need to, move the thing over to another type of, I might have to handle that data differently. But yeah, this works well. So now I got the curve editor set up. All right. So one of the things that needs to happen is I need to generate. There's a couple of these things I don't know what's going on with the other tool, and I really don't know what's going on with the other tool, which is fine. Like, here it is, the Live 2D. So one of the things you can do in Live 2D that I did not realize was a thing is you can actually edit the individual vertex and move it, and now the grid stays there. Now I have no idea what this means on relationships to everything else when then you start changing the curves, because that just seems absurd to me that you can change that. It seems like it does nothing until it like becomes extreme, because you can see a bit of a slight dip right there in the edge of the eye shape. But then if I do the same thing, no, I still get the same sort of dip in the eye shape. So it's really interesting. I'm not 100% sure what goes on in that, why you're allowed to move these vertexes. Like, why do they matter if you can move them? They don't seem to impact anything that I know of, but I could be wrong. I don't know if there's any other mesh shapes on this. This looks like it's not a mesh shape. The eyes are the only mesh shapes here. These are the mesh shapes for that area. The other thing I don't understand is like how, so how does this mesh shape affect the entire subset of the things that are inside of this mesh shape? Like, how does this deformation mesh know to only affect the things that it's supposed to affect, right? To me, this seems weird that these all of the eye pieces are patched into this one thing. How does this know what it actually affects? That's what I'm not 100% certain about. Yeah, it's so strange. It looks like it. Oh, that's interesting. Oh, okay. So this is. Oh, this is. All right. I don't get this, but so this is the deformer specified with these items underneath of it. But over here, there's like a whole hierarchy that's slightly different than what this hierarchy is. So what's the difference between this hierarchy and the part hierarchy? Strange. I am to a point in this where I could be at a stopping point. It's kind of a natural stopping point at this right now, because I'm not 100% sure what to do with this the grids I want to generate, because I don't know if I want them generated, like, do I generate them in real time or do I generate them and then warp them, right? Oh, I know what I need to generate next. I need to generate the actual warping grid, the thing that's kind of invisible. So on in Live 2D, the underlying warping grid, that's what I was kind of getting at. This gizmo here, this grid you see is actually not the grid that's being deformed. That's not the math that's actually deforming that grid. So I need to be able to, I need to generate that stuff. So I need to figure out how that's going to work. Which isn't that hard because I can get the patch depth and all that stuff. And some of these data structures I've created, they may end up being more of like the UI based data structures. They might not be the data structure that works well for the rest of the back end portions that kind of do all the hard work, the heavy lifting, as they say. And then I've also seen the deformations like underneath other deformations in a way that it's very obvious that they mutate, they warp each other in some way. Yeah, like this one has all of the eye portions of the like the right eye, and then the eye internally has its own deformer. So there's this deformer that seems attached to that, and there's another deformer that does, oh, the head. Oh, I see. So this is the perspective shift. The amount that the eye transitions is really subtle. I don't even know if it's necessary. Like I mean, I guess it looks right. Like it's weird. Strange. Okay, but I get what's going on. There's an overall deformer for the eye itself. That's probably yeah. There's one for the left and right that does the same perspective shift, and then internally there's the one that controls the eye opening and closing. Interesting. But see, I don't understand why there's this why you have these deformers just sort of listed as elements inside of this, but then you don't have, or maybe this is the eye itself. Okay, I see. This is the eyeball open and close deformers, and this is the perspective shift performer deformers. These are probably also perspective shifted. Yeah. Oh God. Yeah, so once I get the grids map, once I figure out the grid warping stuff, and then figure out the actual correct way to move these control nodes, so that they do the right thing when I drag them around, they follow the same, they track in the sort of same way. Um, Once I get that down, I can start working on like what it would look like with, say, an XY, you know, like a XY deformation against it. Like I can define limits and stuff like that. We can start to figure that out. The underlying problems I'm going to run into right now are, you know, this data structure handles only this idea of a deformer that allows me to select like one item and move it around the screen. I can't do multi-select. It doesn't have the way of supporting it. So mixing the UI with this mathematical structure could get painful. I've seen it get painful. It's one of the things you gotta deal with. And that's just how it's going to end up being. So I'm not 100% sure how that's going to work. So let me try generating the grid that looks like what the internal grid looks like here. And I'll mess with that for a little while. And then another thing I need to do before the stream is over today, I need to do this. I never did a git init on this. One second. All right, so I need to add a whole bunch of stuff. That actually looks like most all that should be added. App.js, I'll just do app star. We'll add the end file, the prettier RC, the VS. No, we don't. I don't care about the VS Code thing. Notes. Source app. There's basically everything there I want. Source CTX. Oh. I don't think there's anything in the lib folder yet, but we'll add it. Git add source React app inv.t. Is that a thing? I didn't know that was a thing. I don't know what that is, but I guess we use it some. Whoops. Well, cat add, git add source setup test.ts, I guess. Add ts config json. Source index.js git add. Logo, source, report web vitals, which I think I deleted. Setup test, git add yarn.lock. I don't think you want to include the git. Oh, right here. The dot for git. It's like a meta question. I probably can't get a straightforward answer. Whatever. Nice. All right, so everything's committed. In order to draw these Bezier lines in a way that is similar to what Cubism is doing, so that I get the same grids that they produce, I need a more complex warp, I think. Is this one? I think these are all really simple, like 1x1 warps or something. So let's see if I can rejigger one of these to being like, can I change it? 2x2, 5x5. I want a 3x3. Oops, not 32x32. 3x3. That didn't work. That didn't generate 3 nodes. I'm lost. Wait, is that one actually set to some? No, it's not even a warp deformer on it. Let's throw one on it. 3x2, 6x6. I want 7x7. I want like an odd pattern. I want them to be on the same beat pattern. Why am I not getting? Oh, there they are. Okay, I just had the wrong controls selected. So what I want to see is this, like I get, I'm defining like this oddball mesh size underneath of it, and so you'll see that the points generate sort of, wonky, right? The way that is generated, the total number of lines that are in the mesh, I think these are all turned into unit. Let's see. I think these are all turned into unit length lines, but then I map the third of a unit to each one of those to generate each one of the individual nodes across this whole graph, and it'll make perfect sense, I think, when I actually generate it. So I guess let's get crack-a-lackin'. So now I need to do another. Let's create another. I'll throw it in the primitives folder. Oh gosh. I open up my node modules folder. That was always a mistake. So in my primitives, I'll also throw in a new file. This will be just a mesh grid.tsx. Now this is just probably not going to be the thing we use long term. This is going to be something I'm using just for now. It's probably going to need a good chunk of all of the stuff that we see here. It's going to need a whole bunch of props. I would get. Oh, I guess no. I just need to send it the mesh vertex. This is mesh grid, and then I do export type mesh grid props. So this is, I guess, ostensibly just going to be an array of like just small points, right? And then like an array of a whole bunch of straight lines. But I need to generate those lines with the Bezier functions. So I want to grab, I'm going to open up my, this is all the stuff we wrote on day 1. And I need this point at is actually what I want. I probably don't need much anything else actually out of that file. But we're going to get point at, and I'm going to do a function point at like this. And so this takes unit vector, so this is a number, and this is points, which would be vector 2 array. All right, so this is vector 2, new vector 2. I should just be able to port that right over. Yeah, it just comes right over. No questions asked. It's great. But we also need to be able to do a compound line point at, I think, is going to be important. I'm trying to think of how that would work out. So I want to do function compound line point at, and this would be, I don't know, I just do points vector 2 t number like this. And so what I want to do is I want to say, you know, I just want to say lines. We just say lines, and the lines is an array of vector 2's array, because that's going to be all the different like actual points on a Bezier curve. And I want to get the points along this compound line. Is this right here? So what I want to do is I want to turn this line, this set of line segments, into a single solid line, at least conceptually. And I want to start then cutting this line itself up into equal segments, not necessarily segments, but equal parametric segments or whatever, right? And I will do that by, so this will have 2 lines. And I want to just say, like, I will take the t. So, you know, if you give me 0 to 0.5, is that inclusively supposed to be the first line, or should I do like how do I cut that? Well, I don't know. All right, so I will take the lines.length. I will take t divided by lines.length. Right, so this would be, so I need to figure out the cutoff point for each one of the lines. Oh, this is kind of like the line walk thing I did on the other. Oh yeah, that's interesting. So in the Python code, I did a line walk where I was trying to get the path to a point on the line. And this is, let's see, so yeah, I just want to take this, I want to cut this number up. No, I want to take 1.0 divided by lines.length. That's what I want. That's why I was, okay. Right, because yeah. So this will be 0.5, right? So const x equals this. And then I want to say for I don't know, let I equal 0, I is less than lines.length. And if t is greater than I times x, so let's say that we have 3 lines here. So let's think this rationally a little bit. So if I happen to have 3 lines, and I come in and I want the point that is 55% or 50% on the total set of 3 lines, that means I'm going to cut the first line in half. Oh, sorry, no. So the first line is going to be 0.33. So I want my current position to be greater than I times x. And I don't want to go to lines.length completely. I want to go to lines length minus 1, right? Because it's going to be 0.3, 0.33, and 0.66, and 1.0. And well, 1.0 ends the whole line segment anyway. So and t is less than I plus 1 times x. Probably shouldn't have used x. This is going to be, we'll just do LL. LL, because that might get a little confusing. Why is it not? Okay. Yeah, it didn't run prettier. Oh, it's because I got, okay, I plus plus. Okay, so this then is saying, hey, you know, if my number is greater than the number that I'm currently at, and the end of this number, the line is literally at then I'm going to pick that. Well, I could also just, yeah, why am I doing that? Because all I got to do is figure out what index it needs to belong to. Duh. Right? Because then I need to, I already wrote it. I don't care. So now that I have the line that I want the points at, I just do lines, and then I also take I times LL. So let's say that we are at 1.5 and we're at 0.33 for the start of this line, 0.66 at the end of the line. That means I take, you know, this number and I subtract I take t and I subtract this from it, and I just return that. And the lines is a bunch of vector 2's, lines I, something like that. And I feel silly because I could probably just calculate the index now that I stare at this, but I don't know, whatever. So I need to generate all of the horizontal lines. So mesh grid props needs a mesh grid. So let's look at the, I don't need the reducers. I do need mesh grid. I probably need to, I don't need to look at that for now. And here, where's this one? Nope. So I do wow, there's a lot of stuff here. This guy. So this is where I generate my horizontal and vertical lines, right? H line, P line. Did I not ever? Oh, I didn't do the Bezier for the other lines. So it's fine. It's not important. We'll look at that in a second. It is compiling, so I could fix that. So this only does the Bezier lines on the verticals, not the horizontals. So let's do that. It's going to be the right line, so it's up, down, left, right. So this is going to be 3 and 2. It's weird how that's worked out. And then it should no longer be this. It should just be this. And it should be H line, H line. Yeah, that worked out really well. Nice. I can't grab the node anymore. Did I break it? I think I managed to break the page. Oh no, there must be overlapping. Something's overlapping on that node. They're hard to click. I need to find a way to make it so that when I mouse over them, I can highlight the one that's closest to me or something. That might just be a better option than what I've been doing. I'm relying on the HTML and the browser to give me the data points back. I hate to say it, but it might be better if I did all this stuff very manually. Yeah. I need to also make it so that this, when I modify this, I can maybe hit a button to save it to local storage, so I can constantly come back to my modified, currently edited grid mesh node thing to kind of get an idea of like, yeah, that'd be pretty nice. Okay, so the mesh grid is going to take props of this warp mesh vertices. And then we're going to iterate over it very much like we did here for the vertical lines, except I'm going to come up with the set of 3 vertical lines. Right, one thing we don't have data for right now will be the grid size, the actual number of cells. So I'm going to generate a 7 by 7. We'll just say, I don't know, width 7, height 7. So I generate an oddball number compared to the number of vertices I've got. I got 3 vertices and 7 boxes to put inside of them. All right, so we're going to iterate over all of the x coordinates. This is the vertical line set. And then we're going to go, I don't know why I dropped the width and height. Why did I do that? Okay. So I got going to go for the vertical, so left to right vertically. I'm only going to go top to bottom twice. This will then give me my lines, or not twice, I should say. I just go top to bottom 1 minus to just generate individual lines. So this will give me my const v lines, or yeah, equals this guy. And then I can say with v lines, I can push them if C1, C2, I can push v lines like this. V lines dot push, and then this will be the P1, C1. Let's see, C1, C2, P2 into that. Why is it mad at me? Because it doesn't know what it is, and I don't care to know what it is either. And this is going to be the warp mesh vertices. I will just extract that up here, like that. Like this. Let's see. Yeah, this should be right. And so now that I've got the individual vertical lines, one of the issues I think I'm going to run into is that I'm pretty sure that the nodes are interpolated across the grid itself. So, right. So like if I generate this line here, I have to generate a new line for this line segment. Because I'm pretty sure it doesn't map. I don't know if I don't think it's linear or something like that, but I'm pretty sure that the control nodes, this draws like this. Well, this one draws subtly different than this one. And I suspect, yeah, see how the control node's not moving that vertex, that line aggressively? It's because this actually interpolates linearly over the entirety of this path. Oh, Jesus. So in order for me to get the control node line for the next node segment, I need to interpolate this line with this line, this percentage. So I'll have to do the mixed nodes. This might be a little beyond what the scope of this. I probably won't be able to finish anything in a timely fashion. So I'm going to go ahead and call this a night so I can think about this a little better. It's been great hanging out. Didn't get a lot of people today, but that's fine. We'll do something better tomorrow. So hopefully this will get interesting to people, and we'll build it up from there. So thanks for watching. I'll see you guys later.